Hi all, this is Bharatraj. Today my Java Tech Talk topic is about primitive data types in Java, matter of applications. Now we will see what are the primitive data types in Java. A primitive data type is specify the size and time of variable value, and it has no additional methods. There are eight primitive data types in Java. Uh, the eight data types are byte, short, int, long, float, double, boolean, and char. Uh, byte takes a one byte size, that is one byte equal to 8 bits, and short takes 2 bits, that is 16 bits, and int takes 4 bytes, that is long takes 8 byte size, float 4 byte size, double for 8 bytes, and boolean is 1 byte size, and char is 2 bytes. The description of bytes is store all numbers from minus 128 to 127. We'll see the description of short stores number from minus 32,768 to 32,767. In long, we can store whole numbers, and in float, we can store fractional numbers. In float, we can store fractional numbers that specify stored to 6 to 7 decimal digits. In double, we can store specify storing 15 digit decimals. In boolean, we can only have true and false values. In char, we can store a single character or letter or an ASCII value. Now, uh, it is normally mandatory to initialize class level instance variable. If you do not initialize instance variable, compiler will assign default value to it. Generally, generally speaking, this default will be 0 or null depending on the data type. If you not initialize the data type, that default takes it to 0. And replaying on such default values, however, is generally considered bad coding practice. The following chart summarizes the default values for the above data types. Byte take default value as 0, short take default value as 0, int take 0, long take 0L, float default value is 0.0, double default value is 0.0D, and chart default value is slash u triple zero, and boolean default value is false or true. Now, significance and exponents and loss of precautions. Uh, it is easy to understand losing the fractional part when you assign through a cast a float to int. But what does it mean to lose precious when you assign for example a long to float? The answer lies in how the float managed to have a wider range than the long, despite using only half the storage. Floating point numbers in Java, in fact, in most computer languages, uh, doesn't count in units of one the way that integer values do. Instead, floating point number count in what might be called a variable chicken size. This term is used in article, but is not in current technical term. Although it's possible that a floating point value is counted in of 1, it might be counted with size of 1 by 6 or of 1 by 512. These base our floating point value handle the fractions. Now, but similarly, the number of might be counted in a of 256. This is how floating point value can be a huge number, and thus float point values have much greater range than might be expected. In issues, a floating point numbers storage is split into two types. One part stores the number of chicks, technically called the significance, and another part indicates the size of each exponent. Because Java works with binary numbers, everything is represented in power of 2. A floating point value is indicated as a significant start 2 power exponent, or to write it over in more conveniently mathematical format, that is floating point equal to significant into 2 exponent. With that background on floating point number representation, let's get back to the idea of loss of appreciation. It turns it turns out that for a float value in Java, the significance that use 23 bytes and exponent is 8 bytes. The extra bit is for a sign to indicate whether the floating number is positive or negative. Thus, the largest value a float significance can represent it without making a approximation is 16 lakhs 77,700 216. This is much lower than the largest value of any int and very much lower than the upper limit of a long. If you try to use float value to store a number bigger than that, the exponent that is must be increased. Initially, the count size is 2, and then after 2's, the count is by 4. In other words, it starts out as following. We will see an example, that is floating point value is equal to significant to 2 power 1 up to 16777 Now we will see another floating point value equal to significant into 2 power 2, that is up to 2 power 16 comma 777 Uh, the third one is up to 2 power 4, that is 4 power 16 777 However, the significance remains a 23-bit value, which limits its precious. This is why that separately floating point value from the integer, which have smaller range but greater precision. There are immediately demonstrate consequences to it. This first, if you try to assign a literator to that, you can demonstrate this early by casting those literal value to float and then casting them back to int. System.out print int float uh, 11666217. Then we can print as it is system.println int of float. Amin, Amin. Another effect that is even more significant is what happened in this loop. Try to guess how many times the following will print the string incrementing. The copy the following code and finally out of you were right. This is a program that is float count equal to some value. The we will executing a while loop that count is less than the given value. Mm, we will increment that is count equal to count plus 2. Now the point here is that loss of precious means just that when you assign an int to float or long to either a float or a double, you might end up with an approximation of your original number. The approximation might have practical consequence for your code. Side note means that is double is the default data type for floating point numbers in Java. If you're interested in more details, Java use the IEEE standard for floating point arithmetic for the floating point representation. Now, effective storage of numerical data types. The discussion is now complete. That right will no look back at figure 1. The second column is why not specially used to for the floating point value. The Java specifies the mandate that behavior must be exactly compared with the IEEE. The bottom line is that all through the table description what the numerical behaviors will be. You simply cannot assume that allocating 1000 int variables with allocate 4 bytes of memory. The conclusion of this topic is Java, like most programming language, supports both integer and floating point value for a variable and constants. The Java compiler will let you assign a lower range variable or constant to a variable with a higher range data type because it won't allow you to lower the gross value. Thus, you can assign a float to double, but you can't assign a double to float. You can override this restriction for the casting if you are sure the value will fit. By contrast, the Java compiler will allow you to make an assignment where the could be a loss of species that you can assign a long to float even though the resulting float may only approximate the original value. Thank you.